Hello and thanks for your interest in this class about GeoJSON. You may have heard the name and don't know what it means, or you may know what it means but you want to learn more. Either way, you're in the right place. GeoJSON is important because it's becoming a core technology in internet mapping for sharing and displaying spatial data on the internet. GeoJSON is a specification for storing geographic data in JSON form. You can store vector data, which are points, lines, and polygons. And you can store the attributes. Basically, you can store the same kind of information that you store in a shapefile, but it's stored in a single file as text, and that's important. So what is JSON? JSON stands for JavaScript Object Notation. And JSON is a text form of JavaScript objects. If you make a web map, people will be viewing it in a web browser, and all web browsers understand JavaScript, which is the programming language that's used in web browsers, so it makes sense that web mapping applications use GeoJSON. JavaScript stores data in objects, but JavaScript only understands binary objects. Fortunately, JavaScript can easily convert a binary object to text, and that is exactly what JSON is. And of course, JavaScript can also convert JSON back to its binary object form. And why do we want to do this? The main reason is that text is easier to deal with than binary objects in a web page for a number of reasons. Text can be stored in a file and edited directly in a text editor. And text files can easily be sent back and forth across the internet. Text can also be stored in a database field or web storage, so if you have a way to store coordinates in text form, you can store coordinates in a database, even one that is not spatially enabled. Okay, enough introduction. Before we dive into the video, I want to mention that this is one lecture in a course I created called Introduction to Web Programming for GIS Applications. This course also includes 97 other lectures, which is over 13.5 hours of video about the basics of web programming with a specific focus on GIS applications. This course is available on the Udemy platform. Like all Udemy courses, it can be viewed anytime at your pleasure. It can also be viewed anywhere. You can download the course to a mobile device like a tablet or even your phone, so you can watch it even if you don't have internet available. You can watch it in the middle of the ocean or on top of a remote mountain if you want. And it's available for life, so you can take as long as you want to finish it. Just to show you my appreciation for watching this video, I'd like to offer you 65% off the course. It's normally $100, but if you use the coupon code GeoJSON, all in capital letters, you can watch the entire course for $35. The URL is here, but you don't need to type the entire thing in. You can just go to udemy.com and search for WebGIS, and this course will show up. I don't think it's the cheapest, but it's a lot longer and in-depth than the others. You can also check out my blog, Geospatial Brainstorming, for more information on GIS, and especially WebGIS. Okay, enough self-promotion. Here's a lecture. I mentioned previously when we talked about JSON that there was a specification for storing geospatial data in JSON format. And that is exactly what GeoJSON is, a specification for creating, identifying, and storing geospatial data in JavaScript object notation. It can also be used with several mapping APIs. It is a core technology in Leaflet, the mapping library that we will use. It can also be used with Google Maps API, the OpenLayers API, and the Esri JavaScript API with an extension. GeoJSON can also be used in other software. QGIS can read GeoJSON and save any type of data that it can read in GeoJSON format. Also, PostGIS has built-in functions that can output its binary data into GeoJSON format, and these two things are going to be very helpful to us throughout this course. Turf.js can also perform spatial analysis on data stored in GeoJSON format. PHP and most other server-side languages have the ability to read and encode JSON, so it can be processed in server-side scripts as well as in JavaScript. Finally, we mentioned that NoSQL databases store data in a JSON-like format, so it is a smooth transition from GeoJSON to a NoSQL database. And even SQL databases can store GeoJSON because it's text. So even a non-spatially enabled database can store GeoJSON as text and pass it to a mapping API to be displayed on a map. So hopefully you're getting the picture that GeoJSON is one format that we can read in all of the open source software packages that we've mentioned, and that makes it very useful. Most importantly, since we know how to deal with objects and arrays in JSON and JavaScript, it's no mystery for us to read and process GeoJSON data in whatever manner we want. It's nothing that we haven't seen before. And with that, I hope that you're convinced that it's worth spending a bit of time on, because we're about to jump deep into the GeoJSON weed patch. The simplest type of geospatial geometry is the point. A point is just a single set of coordinates, x, y, and possibly z. All GeoJSON geometries consist of at least a type property and a coordinates property. For points, the coordinates property contains an array of coordinates, in this case, -108.5 and 33.7, and those are longitude and latitude. There could also be an elevation as well. We know how to access the coordinates in JavaScript because it's just a standard JavaScript object with a standard JavaScript array. So to access the longitude, -108.5, we call the coordinates property with the 0 index to indicate that we want the first element in the coordinates array. And to access the latitude, we call the coordinates property with a 1 index to indicate that we want the second element in the coordinates array. Now all GeoJSON geometry types also have a multiform. So in addition to a point, there is a multipoint geometry type. The multipoint can contain several points in the same geometry. So the coordinates property in a multipoint object is a two-dimensional array, or an array of arrays. So the main array has 3 elements, and each of those elements is an array of coordinates, with 2 elements in each. So coordinates 1, 0 equals -108.4. This is the first element of the second array in the coordinates property. What would coordinates 0, 1 be? You can pause this lecture and think about it for a bit if you want, because I'm only going to pause about 5 seconds. Coordinate 0, 1 is the second element of the first array of the coordinates property. So the first array is up here in red, and the second element of that array is 33.7. What about coordinates 2, 0 and coordinates 0, 2? Okay, go ahead and pause this video and think about it for a bit. Think you got the answer? Coordinates 2, 0 is the first element of the third element of the coordinates property. Now the third element is the green one, so the first element of the third array is -108.6. Now what about coordinates 0, 2? Okay, this was a trick question, but I didn't do this to confuse you. Rather, I wanted to see if you really understood what was happening here. It's very important that you understand this because we are soon going to be talking about 3-dimensional arrays and even 4-dimensional arrays. So if you don't understand 2-dimensional arrays, you're probably going to have some problems. Coordinate 0, 2 would be the third element of the first array of the coordinates property. And the first array in the coordinates property is the array that's in red. But there's only 2 elements in there, so we can't call the third element of this array. It doesn't exist, and that's why it was a trick question. Now, I think multipoints are available as a geometry type in Esri software, but they are not often used. However, it's an important concept to understand. 3 different points are 3 unique features, and each can have their own attributes. But a multipoint object with an array of 3 points is a single feature and can have only a single set of attributes. And I think this will be more clear after we talk about lines and polygons. A line in GeoJSON has a type of line string that contains a single line. The syntax for the geometry property is the same as for a multipoint in that it is an array of point coordinates. However, because the type is line string, the points are interpreted as vertices for a line rather than 3 separate disjunct points. In other words, the points are connected. A line string in GeoJSON is analogous to a path in the Esri ecosystem. A multi-line string in GeoJSON is what we call, in the Esri world, a polyline. It might be a single line, but it might also include multiple lines. So this multi-line string geometry contains 3 distinct lines that make up one single feature. The first line is the text in red, second line is the text in blue, and the third line is the text in green. And then we surround those 3 arrays with another set of opening and closing brackets, which makes it an array of arrays of arrays, or a three-dimensional array. I really hope you understand this, because in the next slide we'll be talking about multi-polygons, which can have four-dimensional arrays. So if it's not clear, maybe rewind and review this lecture and spend some time thinking about it until it makes sense. And as always, if it doesn't make sense, feel free to send me a question, and I'll do my best to explain it. A polygon in GeoJSON is composed of a single or multiple lines. Each of those lines has the same beginning and end, and thus it forms a ring. And in fact, this is what we would call a ring in the Esri world. The first ring, shown here in red, is always an outer ring. All the subsequent rings, in this case only the one shown in blue, are interior rings, meaning that they delineate holes within the outer ring. This is how you would create a lake in an island, to use the classic example. The island would be the outer ring, the red one, and the lake would be the inner ring, the blue one. And there can be as many lakes, inner rings, as necessary, but only one outer ring. And a multi-polygon in GeoJSON, as you might expect, is an array of polygons. This makes it a four-dimensional array. And just try to understand this conceptually. In this example, there are two polygons in this multi-polygon. Each polygon is delineated by purple brackets. The first polygon is the one that we just looked at in the polygon example. It has one outer ring in red and one inner ring in blue. The second polygon is the green text. It has only an outer ring and no inner ring. And then both those polygons are wrapped in an opening and closing bracket to make an array of an array of an array of an array. Now a polygon in the Esri world has the same structure as a multi-polygon in GeoJSON. This one has essentially two islands, and one of the islands has a lake in it, but they form the same polygon and have one set of features. So this is how we create states like Michigan, which has two outer rings for the upper and lower peninsula, and Utah, which has one outer ring that forms the boundary of the state, and one inner ring that's a hole that represents the Great Salt Lake. Okay, that got a little ugly, but it's an important concept. In fact, PostGIS uses the same data structures to define geometry. Points, lines, and polygons as single geometries, and multi-points, multi-lines, and multi-polygons as arrays of geometries that combine to form a single feature. Okay, hopefully we're clear on geometries. Now let's talk about features. Like all GeoJSON objects, features have a type property, and as you might guess, the value of the type property is feature. Features are a combination of geometry and attributes or properties. So every feature also has a geometry property and a properties property. Sorry for the redundancy, I didn't write the specifications. The geometry property contains one of the geometry objects that we just talked about, in this case a point. And the properties property contains an object with any number of property value pairs. These are analogous to attributes in the Esri world. Finally, you can think of a feature collection as a multi-feature in the terminology of GeoJSON. However, they chose to use the term feature collection. But a feature collection is an array of features. In this case, the features property of the feature collection object holds an array containing two features. The first feature is in purple, and the second feature is in blue. In this case, they are the same geometry type and have the same properties, as is often the case, especially if you get this GeoJSON by converting a shapefile or a geodatabase feature class. But there is nothing in the GeoJSON specification that requires this. There is no reason that a feature collection couldn't include a combination of points, lines, and polygons with very different attributes. And this may sound confusing, but it also provides for a lot of potential flexibility. An important thing to understand is that all GeoJSON objects have a type property. If you know that an object is GeoJSON, all you have to do is read its type property, and that will tell you everything you need to know about how to read its data. If it's a feature collection, you know that there will be a features property holding an array of features. If it's a feature, you know that there will be a geometry and a properties property and how to read them. If it's a point or line, you know that there will be a coordinate property and exactly how the arrays are structured. So it's pretty easy to conceive of the ability to include different geometries in the same feature class. You aren't restricted to a rigid table-based structure like you are with most geospatial data types. For instance, you could model a pipeline with both lines for the pipeline part and points for the different connectors and valves, all in the same feature class and all having different types of attributes. Okay, thanks for your interest. If you want to learn more about web programming for GIS applications, check out my course on Udemy.